Hi everybody, today we're going to look at StatCrunch program. We're going to look at the z-test. We're going to take a look at some problems that we saw in our review earlier this semester for the z-test, and we're going to take a look at that, and we're going to take a look at how we would do this with the StatCrunch program. So let's go to our screen share, and we're going to first off take a look at that review. So we had a part A and B that we did on this review that we saw. So basically the first one dealt with a Macy's purchaser and shoe size. She claimed that the US female shoe size was 7.5. She knows the population standard deviation was 1.6. She chose 250 customers. She found out that the sample mean was 7.62. And we're going to use a level of significance of 0.1. Okay. And so what we found when we did this with the calculator, here's our null hypothesis, mu equals 7.5. This is the claim. HA, mu does not equal 7.5. Our level of significance was 0.1. Our test statistic was our test statistic was generated by using the test statistic formula. But this also was generated with the calculator. We got 1.19. Our probability value was 0.2357. Okay, and again, these were taken with parts 3 and 4 were taken with the calculator. I gave you a snapshot of what the TI gave you in that scenario. And we have 0.2357 is greater than the level of significance, so we failed to reject A0. Since we failed to reject A0, the claim is that the shoe size is 7.5. That is H0 in this scenario. We have to support that claim. Let's take a look at how we would do this with StatCrunch now. With StatCrunch, we have the same problem, and we're going to have the same H0. H0 is the claim here, HA, because it's the same problem, does not equal 7.5. Same level of significance. What we're going to do, instead of generating 3 and 4 with the calculator, we're going to generate 3 and 4 with the StatCrunch program. We're going to take a snapshot and paste it in here. Our p-value is going to be the same. You're going to have the same conclusion. So let's take a look at how we can do that. So I'm going to do a stop share here, and then I'm going to share again. But this time I'm going to do StatCrunch. Okay, so here's the StatCrunch program. I opened it up. Okay. If you look, you have z-stats, t-stats, and proportion stats. All have 1 sample and 2 sample possibilities. Since we know what the population standard deviation is, we get to use a z-stat. We're going to select 1 sample because that's all we have. And we have with data and with summary. If we have a list of data and no sample mean is calculated, then we have to use the data feature. Since we have no list of data and we're given a sample mean and a sample size, we're going to use summary. So we select summary. The sample mean, if we recall, was 7.62. The standard deviation of the population was 1.6, and the sample size was 250. Our null hypothesis said that the shoe size was 7.5. HA, just like with the calculator, you have to select the symbol in HA. In this case, it's not equal to, but there are also the less than and greater than symbols, which can also be in HA. We're going to press compute. You're going to take a screenshot of this, and this is your part 3 and 4. This would be the test statistic, and this is the given p-value. Pretty much the same as with the calculator. So let's stop the screen share. Let's go back to the review. So the review, we would paste that input, or output rather, here, and our conclusion would be the same. Let's take a look at how we can do confidence intervals. So now we're going to go back to this. We're going to go back to the StatCrunch. Okay, so we ran our hypothesis test. We got these results. So let's take a look at confidence intervals. For confidence intervals, we go back to z-stat, just like before. 1 sample with summary. And if we look, you have a hypothesis test format, and you have a confidence interval format. So we're going to click on confidence interval. And we're going to choose, in this case, how about 0.90? And we're going to compute, whoops, I forgot to put this stuff in, 7.62. Got to put that in again, 1.6, sorry about that, and 250. Now let's compute. There we go. So our confidence interval where it says L limit, that's the lower value. U limit is the upper value. It gives us an error. The error, it tells us, that's a standard error. That's not the error of the confidence interval. That's a standard error, which is the standard deviation divided by the square root of the sample size. So don't think that's the confidence interval error. To find a confidence interval error, you have to do the same thing you did with your calculator. Take the upper minus lower value and divide by 2. Okay, so hopefully this helps you out. If you ever have to do a confidence interval, you can take a screenshot of this and paste it in as well. So let's go back now one last time to that review. I know we're going back and forth here. I apologize for that. So what do you have to do? So there was a second problem in this review. The second problem was B, and it dealt with car manufacturer and gas mileage. Okay, they claimed it was more than 28.5 miles per gallon. Okay. You have a random sample of 38 cars. The mean of that sample was 29.5 miles per gallon. The population standard deviation, you know, is 1.1 mile per gallon. So you're going to test this claim at the 0.05 level. And you're going to do the same thing we did here, except you're going to use a StatCrunch program to generate 3 and 4. You're going to take a screenshot of it, and you're going to send it to me. Okay. You're also going to do the confidence interval for that information. Oops. There, by the way, was the screenshots that I talked about with the calculator. You're going to do the 95% confidence interval for this. You're going to interpret it. Remember what the interpretation part means. That means you have to know what the error is, not the standard error. Not when we take the 1.1 and divide by the square root of 38, but the error of the confidence interval. Upper minus lower divided by 2. And you have to interpret what it means. In this case, there'd be a 95% chance that the actual mean miles per gallon would be between the two limits. Okay, so hopefully this helps you out. So again, you have confidence interval and you have hypothesis test. Okay, you're going to screenshot your output and you're going to send it to me. Where do you send it? Well, there's a place under assignments where we have all of the StatCrunch program assignments. When are they due? They're due at the end of the semester. So have a good day.